Okay. So I have a lot of my community members, and they will be joining slowly. So let's just kickstart, and the rest will come and meet us. Yeah, because we have only like 1 hour to spend on this Google Meet. So let's just proceed. Emmanuel, can you hear me?
Yes, I can. Just
All
give me
right.
1 second and I'll
All right.
join. Yeah.
Okay. Yeah. Why is this at all not working?
Hello, can you hear me?
Yeah. We can hear you.
Okay. Is the audio quality better or worse than before?
It's. I'll say it's better. It's better.
Okay, perfect then. Okay, so I'm just gonna turn on my webcam for the presentation. Let's try that back. Yeah. So, uh, is it good to kick off?
Yeah. Yeah. Let's just kick off. Yeah.
Okay. So this is the what I'll be sharing today. A lot of the talk is really going to be abstract stuff. Because there's really no way to definitely say this is everything. Um, but based on context, I'll share like some links at the end. Then I'll just go into like details on like some of the really technical stuff. But we'll start off with like just the basics. And during the presentation, I might just cut off for a bit, share one or two things um, that I think would be worth the discussion. And we'll just continue from there. So the topic is becoming a site reliability engineer. Lots of the site reliability work is usually with software and operations. So just like some history here, back in the days of like DevOps, like the core DevOps, DevOps is not really like a field. Just to start off, DevOps is more like a culture of optimizing releases for end user comfort. So that's a more customer obsessed, business operations in regards to software delivery. And the focus on DevOps was that okay, the developers have no idea what the product guys are doing. The developers have no idea of the systems around their code. The DevOps guys would then come in, so we understand what the customers would prefer, like the customer experience should be like, oh, we're going to run it on the front end, or we need to run it globally, you need to use a CDN. Those kind of like technical decisions would then be taken out, and the DevOps guys would handle it, right, based on like guidelines, good design that they've already found over the years of running it, and they would handle that. So site reliability is let's call it a sub career choice under DevOps. In DevOps, you have like very different stacks. I can actually show what that's like from a talk I gave some years back. What DevOps is really about. You can just cut here. Can you also see my screen clearly?
Yeah, we can.
Okay, so I'll just share this also within the chat. So like I'll just scroll down here. I gave this talk like some years back, like really long back. So as you see, it's a culture, and in the branches you have the typical sysadmins. These were the guys that mostly orchestrated servers. They had large data centers running in someone's office. Lots of things. Net operations, like in AWS. I don't really do like SRE the way Google does it. I do mostly network operations with a mix of sysadmin. So it's kind of like you can have multiple like what do you call it focuses within DevOps. Even though you might do SRE. So SRE is kind of like the aggregate of most for big tech. Some companies might have they just specifically want sysadmins because they run data centers. Some might just want cloud ops. Most DevOps teams usually just need cloud operations engineers because they just run on AWS. They never think about anything like networking or Cisco routers. There's no data ops guys, those running storage, there are like various things. There's HR operations too, hiring procedures and everything. So when you think of DevOps, DevOps is really multiple branches. It's not like one single career choice. During the call, like if anyone has questions, you can unmute and just like raise like the question, and then I'll just pause and answer you so that we can share that interactive session going. Yeah. So the general idea here is that SRE is different. In SRE, you mostly write more code and you also blend with the operation stuff. So SRE is mostly like automation. Like you're thinking of ways to speed up delivery of like the manual stuff. The other systems admin guys, the cloud operations guys, usually they blend a bit of the SRE culture in between. But SRE is mostly focused on automation, software, and writing code that does manual stuff for really big teams. So enough about the intro. What do I do? Where am I? People call me Backman. It's very generic. A lot of people don't even know my name is Bakari. A sad story. But I do systems engineering at AWS. What that entails is, for me, is mostly networking stuff. So load balancers, routers, networking, L3, L4, L7, and lots of stuff in between. I also write code, automate a lot of stuff that makes that happen, and lots of technical doc writing, the usual stuff. I'll explain more about that later in the talk about like what that experience is like. Also lots of experience fixing and breaking stuff. So this usually involves things like on-call rotations and incidents recovery. So whenever I hear incident recovery, it's like, oh, something broke. How do we fix it? How do we improve it? What are the guidelines we should follow in doing so? Is this a repeat? Do we improve the systems? A lot of those things are mostly cultural views that SRE embody, and those are the things that I've learned working at AWS. If you really want to check out some of the stuff I built, it's on GitHub. I'm not so active there these days, but there's a good chunk of stuff that I might interest you. And I'm mostly on Twitter these days, so you can follow me there also. That's in my background. So what's really site reliability and what's site reliability engineer? Usually it's just you're responsible for maintaining, enhancing, lots of buzzwords here: availability, performance, blah 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 blah. The key part of the SRE culture is usually in enhancing. So SREs usually come about when teams grow too big that even the sysadmins can handle all the work. Sysadmins usually handle, and this is based on like this. I'll just switch back to this slide because they're kind of like a mix. So usually, generically, there was only sysadmins. So people mostly had sysadmin guys that did most of the work, and they usually had some networking guys who were a mix of sysadmins, but they didn't really write too much code, and they didn't like really build systems that would enhance writing code. So for a majority of the systems that were built, you had to, figure out, oh, is there Terraform? Oh, is there something like Terraform that could work for this? It was a lot of like back and forth. So SRE came about because teams were like, okay, now we need people that just focus on maintaining stuff that already exists and improving the delivery. So the delivery is like, oh, before we had a server and would push code to it via SSH. Now we're like, okay, fine, we need a pipeline. We need all that stuff. The typical DevOps guys of the back days didn't really think about that. But the SREs are now like, okay, this is it. This is actually something that if we improve, we get better delivery, it improves the business, etc. etc. So that's where this key software engineering practices. We now take all the stuff that people will do manually, we automate it, and then we find much smarter ways to improve it. That's what this entire block means, even though it's just a summary. So the roles, as I've said before, is the same thing: automating tasks, improving. But there's also the parts about ensuring system stability. What that entails is that things break naturally because people make mistakes. And in AWS, like there has been a lot of mistakes. Like, even I once made a mistake that took down CloudWatch for like 5 minutes. Right, it came back up. But it was a very weird mistake, right? And the thing is that like usually when that happens, what the SREs do is that like we have incident recovery. That's this responding to incidents. What we do there is that we're like, oh, something went wrong. Why did it go wrong? How did it go wrong? Is there any way we could have prevented it from going wrong? Is this a systemic issue? Like, is it cultural? Right? Do people go do this thing because it's a standard? You know, kind of like the way you think about the way Nigeria is. You're like, oh, do I go enter a Danfo or do I take an Uber? You know, taking the Uber is more expensive, but it's generally more comfortable. The Danfo is more friction, but it's usually less expensive, and then you weigh in which particular path might be easier. Oh, there's a BRT in the middle, right? It's a bit expensive. It's also comfortable. So maybe we can take that too, right? Those parts, that's what SREs kind of discuss when incidents happen. And that's then the final part here where we say aim to reduce the impacts. Usually we think of ways to improve the systems, and that's the generally missing parts from like past DevOps branches that evolved to then become what SRE is today. So to summarize, we generally improve the way things are. We fix issues that's based on incident management, and then we also find ways to make them better. That's via means of postmortems. There are like a lot of postmortems that you find online. There's a particular one by Dan Lu. I would share that data on the talk so we can speed up. SRE does not have the same name in different companies, and it goes by different terms. Some companies just call SREs DevOps engineers because you guys just do everything. For more large teams like AWS, you can't say DevOps because why? Um, those branches evolve to be very specific, right? And the terminologies you use give rise to what the team thinks about. So if there's a network operations team, you don't expect to be doing SRE work by writing code for automating a ton of stuff. No. Like you usually expect that they are working on the networking layer, responding to customer calls and incidents, setting up infrastructure in the data center, or managing data center operations work, etc. Right? Site reliability engineers do more coding and the system stuff. So they go by different terms. In this case, in Meta, they call them production engineers. In some other like YC startups, they're called infrastructure engineers. The previous company I worked for, I was an SRE, but I was termed an infrastructure engineer because that's the term they use. In AWS, they call us systems engineers, but SRE itself evolved from Google. So Google, by definition, calls people SREs, and that's why it's the landmark term for this kind of work, because they coined the term. And I'll share like the SRE handbook later on like how those systems came to be. We all do the same work. So as a systems engineer, I could leave and go to Google as an SRE. I wouldn't really have much of a difference in the work I do aside, cultural stuff and how the team operates. So as you see here, so DevOps again is a culture. It's not a job. Site reliability engineering is a job that embodies the DevOps culture, right? And as you see, it's a culture, it's collaboration and continuous improvements. You're looking for ways to speed up delivery, and usually Agile is the most preferred, what do you call it, model for doing that, because you cannot do like a Kanban or waterfall because usually things go out of sync very quickly. There are blockers, so you deliver what can be delivered to make the customer happy, and then you continuously improve that in sprints. And most SRE teams do that. They use the agile workflow for delivery. Continuous integration, automated deployments. I've spoken most about this before. Site reliability engineers, they play one of the biggest roles in DevOps because their own methodology is one of self-improvement and also automation, which makes it very, very, very strong in any organization because their delivery is just next to none. Like if your idea is how to make the business move faster, generally you get tons of funding and focus. So in my own journey here, I'll just coin it like this. So it's been a lot of challenges. Typically, lots of learning, right? Because when things break, you never know what breaks, right? It could be the software. I've actually had to use GDB for those who might not know GDB. Like it's a debugger. I didn't write the code, but I had to check why the code wasn't running. And it goes that far. So when things happen and they break, you kind of are responsible for triaging the problem. And if you don't have as much experience, you get someone from the team that owns it to triage it with you. So generally, SREs also tend to have very good understanding of how the application works, alongside how the application will run, right? So we're kind of like in the middle. We can write the code that the service teams are writing, the software guys are writing, and we can also build the infrastructure that it runs on. And that's very valuable experience because it means that you never go out of sync with with the services that run in those infrastructure. Sometimes, even though you triage the issue and you also learn how to write the code, sometimes you really never know what the root causes are. And usually that's, I think, one of the most difficult parts that I found because the SRE culture does not allow for unknowns. Usually we have very thorough um, procedures to find, fix, and improve problems that, the organization is seeing. Um, and as I grow, I learned that you just kind of have to keep improving in that process. So the skills, the things that are kind of required to get off. Programming skills are very important. Systems architecture, I will dive into that in a sec because that's one of the most important parts. You need to know how things work from the ground up. Like, oh, how does an operating system boot all the way to why does the Python jail cause issues with concurrency? Or why is the JVM so memory consuming, right? Or why is Go so great at working on different architectures like x86 or ARM? Like the systems architecture builds on top of everything. That is the most technical aspect, and that's what makes SREs so in demand because we know all that stuff, and because we also know how to write code. We're kind of like software engineers with infrastructure experience, and that's a very, very, very good place to be, especially in a job market that has multiple startups. As far as SRE goes, you can never be out of a job, really. Like you just can't. It's the same with front end engineers. They make all the money. Problem solving skills. That's I've explained that in thorough detail. That's the triaging problems. And communication and collaboration. That's generic. Every team requires communication. Every person needs to know how to collaborate. So the benefits. I've like I said, you have continuous learning opportunities. You learn how code works. You build systems that code runs on. You're kind of good to go. High demand and competitive salaries. We get paid quite a lot. I must say, um, a significant amount more than even backend engineers because we generally do a lot of the systems work that the customers end up using. So technically, like in my last company, like even though I was hired for infrastructure, I was still writing code. So in a way, like I was getting paid a lot more than the backend guys. But really my work wasn't too bad because I writing the code made me better at writing the infrastructure. So I was like in a very safe spot. You rarely also get laid off, so your job security is also very strong. Like an example is that in AWS, even during the layoffs, early this year, they couldn't lay off any single member of the infrastructure team because like you just can't lose the infrastructure guys at the company that runs infrastructure that the world uses. Basically, my job security is secure there. And that's just an example of how being an SRE is very, very valuable, right? You typically can't lose. Impact and influence, I just spoke on that. You run things for millions of people. You 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 become more noticeable of problems, right? Because you build the monitoring infrastructure alongside everything. And you also collaborate. You have one of the widest views, probably after product managers. SREs probably get the most view from teams because whenever things break, they have to come meet you then you then go down to them. You also spread out. You speak with almost everyone. And in my case, probably all the way to C level and director level people because you run the infrastructure. Um, some of the lessons I've learned, automation is key, right? As an SRE, learning how to speed things up, like puts you at the front of your game. Monitoring and alerting, too many things, distributed systems everywhere. You can't manually log into a server. It's just not going to work. Failures, as usual, embrace a culture of postmortems and thorough, what do you call it, investigations. And again, collaboration, learning how to work across diverse teams and learning how to speak across diverse teams. There's a different way you would speak with the product manager, right? Not technical, more business focused. Again, say speaking with a software engineer, more technical, less business focused. Again, say your manager, more technical, more business focused, right? There's a balance of everything. The growing demand. This is more just like to highlight like when Google started this. Google actually started theirs. Google was the first company to introduce SRE, which is why the term that they use is embraced across the entire ecosystem. Amazon started theirs in 2011, if I remember correctly, and they named their systems. So it's actually been not too long since Amazon started, the SRE culture in their own teams. Before, software teams managed the infrastructure, and that didn't scale well, especially as they grew to be the number one cloud provider. And demand is always going to increase. Where to start? I'll basically skip this because it's generic stuff, foundational stuff, containers, orchestration, open source. But where it matters is this. Usually, to do site reliability engineering, you need the systems architecture knowledge. And one of the few places I've found this to be useful is in Georgia Tech. I actually did this like early on back in 2020, before getting to AWS, and it was very pivotal in getting in there. I would say like I took courses on computer networking, I took courses on operating systems and advanced operating systems, which come in very handy, especially when you begin to like have large scale problems, right? You can't have firewalls that run on the host. You need something like within the kernel level, like L3, say like eBPF, right? You begin to learn why that is. You also begin to understand a lot of complex things, like when they say Go is very concurrent. Why is Go concurrent? You learn, oh, why? Oh, yeah, because like it's built from the ground up to be concurrent. It has channels built in. Python, not so much. It has issues with the jail and all these things. They kind of come with having deep operating systems knowledge alongside understanding, language design, which you can take from here, which is compilers theory and design. If you want to do data ops, database systems, it's a very, very useful way to build that knowledge gap that kind of like keeps people siloed from growing, in their careers, especially as SREs. Um, and also, as usual, I also have another for the Linux Foundation. The Linux Foundation runs a lot of projects throughout the year. One of them is what I call the LFX. It's basically the Linux Foundation mentorship programs. They pay stipends and it's a good way to get into systems, right? There's things on Linux kernel development and various others. Like there's some on Meshery for, service meshes and Kubernetes. And if you've not really had a job or you're planning to, get a job, it's a good way to also build experience while getting paid. And a lot of the work here is typically SRE focused. So I'm always like, if you can, go for it and apply. These are just the only two that are taking applications for now, but later in the year, especially in January and February, a lot of them do come up on board. So it's a nice way to get started. And yeah, training and certifications. I'm always a fan of promoting trainings and all the other stuff. A very good example is the site reliability handbook. So Google, they basically condensed all the knowledge that they've learned from writing software. It's actually online. You can get it from here and read them online. there's the site reliability workbook, the site reliability handbook. I read this, and it's a very, very great way to understand like problems at scale, issues that come with building, distributed systems, and also, some hilarious things around how culture is also a big problem, like how people react when things go wrong. And certifications. Take as many as possible. You learn a ton. They cost a bit, but usually, like, there are scholarships for these on Udacity. Like now, there's one for this particular program. So, like, if I copy this, and then just come and just copy it like this and just put scholarship. Usually, you find a couple of them that like Coursera does some too. So you can like get exam prep content to prepare for it, and write the exams at the end of the day. Udacity has a lot of them. Yeah, Udacity. I think, yeah, it probably still do, but doesn't seem as common anymore. But I'll just leave this link. For this is for machine learning, but I don't really know about any for um DevOps at this time. So that comes to the end. Thank you all for listening. Does anyone have questions? We're quite early
Right.
in the time, just been 30 minutes, so you I'll say I'm doing good on time so far. Yeah.
Yeah, thank you very much. Um, so yeah, I think we'll move on to the Q&A section now. So whatever question you have, you can bring them up right now. So I have one question. I'm curious. So, um, do a site reliability engineer need to have like an extensive knowledge of backend development, building APIs and the rest?
Usually, you wouldn't need it, but it's very good to have. Um, like, let me give an example. So, like in AWS, not every service runs with APIs, right? Some they just pull data from queues, right? Like an aggregator, for example, it doesn't need an API. Um, but a lot of services do, right, internally. And having understanding of how APIs work would also help you with finding why there's a problem, right? Because APIs are not always in REST, they're not always HTTP. Sometimes you could have like gRPC APIs. Sometimes you could have APIs that are you know that probably work with some other transport layer built in between. Maybe quick HTTP 3, right? The transport could also be different. It could be protobuf or something like that. But it helps. That's what I can say.
Mm, okay.
Yeah, yeah. Having a better understanding of the network is more important. What I mean by that is, like some people have, what do you call it? Like, let me show you an example. So usually, right, like, a lot of times we know REST, but on the SRE side, this is probably what I would study. This computer networking guide. Um, Precisely, I can just take this off and go there. So, like, now this is what I would take: computer networking instead. Um, Sorry, it seems I have to sign in. Oh no, not account. But yeah, so like now I would study this, switching, congestion control, all these things. Like this is what I would take if I were what do you call it? Trying to be like an SRE, because this is actually what matters in terms of writing APIs. Is more about the networking side. Um yeah.
Okay. So yeah, you guys can start asking your questions now. Who has any question? I believe we should have a lot of questions. I can just raise your hand or just turn on your mic. Hello, can you all hear me? I need to be sure because is it my network or what?
No,
Um,
No, we can hear you. I just came um, recently to the call, so I didn't grab much of what's said.
oh, okay, yeah. So, yeah, so those have been here since the beginning. You can ask your question, except you're super good with what he has said so far.
yeah. And if what do you call it, you have any questions that you feel could be answered or related to the topic, I can also take those.
Yeah.
Okay, I do have one question. Um, I know I've not, from what you've said, if you are writing APIs, we should focus on the networking um, angle. Are you speaking on like the implementation, or in my mind, I was thinking the API itself, like the overview, will be designed by a solutions architect, and the solutions architect was supposed to like maybe map that out, have that solution on hand, and then those that will implement it is now going to now determine what kind of technologies they will use to implement it. So they don't have to worry about that nitty gritty or the actual way of, the way the solutions is going to come together. I don't know if my question makes sense.
Yes, yes, it does. Yes. Good question. Okay, so let me start off like this. So for the solutions architect side, usually if you need a solutions architect, you're getting a consultation. And Similar to our SRE has different branches, there are different solutions architects. You could have a cloud solutions architect, you could have a networking solutions architect, you could have a database solutions architect, right? For companies that run large databases like banks, for example. They cannot just like spin off a Postgres instance or a MongoDB instance and get going. They need to like know, oh, how will this affect what I'm running? And usually those branch of solution architects tend to be DevOps engineers, SREs, right? Not SREs per se, but they're mostly like under DevOps, they embrace the same culture. Um, and what they usually do, again, linking back to the consultation, is mostly drive the design at the start. Now, the problem with doing anything, as you understand from writing code, is that things change, right? One implementation today might have issues tomorrow. And usually, you'd have hired a DevOps engineer on your own team to continue what the solutions architect had presented and implemented, and probably finished and left. Um, and then that's when deciphering what the solutions architect did then becomes an issue, because if there's a problem, you need to know how we built it. And understanding how we built it means you need an understanding of the low level stuff, because he came in with that ideology, simplified everything, and then delivered it. So to answer your question, yes, the solution architect can deliver on it. The problem is after it's delivered on it. That's where you know these things that we just discussed and all these principles of SRE do come in. Yeah. I hope I was able to answer your question.
Yes, yes. But it then brings me to another question. Um, uh, I understand that software do change, and to my knowledge, if it changes at let's say the implementation part of it, it's going to have a lot of ripple effect. But if it does change, okay, if it changes at say the database layer, it's going to have a lot of ripple effect down to everything that comes after it. So if an architect has designed something, and then using your example of say the bank want to maybe whip up an instance of a database, and then they want to know if it's going to affect every other thing. Um, they might speak to an architect, so or a solutions architect. What will these solutions architects now they have to now redesign every other thing, or how would they just go about it, about this change? Because change that happens after the software implementation is always very, very difficult to handle, and it needs to be handled with care.
Okay. Okay. I would. Okay, I can actually show you what that's like. Let me do a quick thing on my screen. So generally, what the solutions architect would present. Great question. Also, it's something called systems architecture, right? Is like there's really nothing. I'm just trying to find a diagram that probably makes sense. Uh, Let me just see documents. Maybe I can find something. So like he would present. Oh, that's very old. Uh, would there be like so it would present something like a document like this, right? Like it would basically outline, various things, various scenarios, right? Like this is like a scenario, something like this, right? It would outline like all this stuff, the architecture, the big picture, the user interactions, the data flows, everything like this, and then it would wrap it all up in a way that people could review, right? Like now, he might be like, "Oh, the database needs to be Postgres," but then somebody on the team might be like, "Wait, but this isn't supported in Postgres, and we use it in the code, right?" Say for like a database migration, for example. It could not even be that changing databases. They could just be moving across versions, like from version 4 to version 5. And version 5 might not say have inserts, for example. So generically, this is where the solutions architect would work at, the kind of level is working at. Pre-implementation, mostly detailing what the system has, what it doesn't, trade-offs, etc. And usually, like he writes this very long doc, then presents it to everybody. Now, post-implementation, right? The solutions architect kind of is done and is traded this off with everybody else that should work with it. And then the DevOps guys can review this and be like, oh wait, like I could show you an example. Like if I go down, say to these functional requirements, I'm like, oh yeah, like you're saying the system's times out, and then in my mind I'm like, oh, this cannot really time out because we don't wait for it to complete. We just pass it to a queue, right? Like, do we really now need like a very big load balancer? In fact, do we even need a load balancer, right? Because there's no API that is running on it aside health checks, So cases like this, right, to improve the infrastructure, etc. The solutions architect doesn't do. He mostly just details out what the system has, how it can run, the scenarios that are justifying him doing that, and that's all. And then the SRE guys can review and be like, okay, he's implemented it. It's giving us this design. Okay, we don't need this. We can take this out. You get. So that's where the collaboration comes in. Earlier on in the talk, I gave like a very short scenario of what collaboration is like with SRE culture, and that's just an example. You review, you are what do you call it? You proactively call out cases that are not needed, right? And then you improve on them. I hope that answers your question again.
No, thank you very much. It does.
Yes, no problem. No
All
problem at
right.
all.
YouTube, yeah, you can go on.
Yeah, so I had a question. What sort of Linux knowledge did you need when interviewing with AWS?
Okay, a very good question. A lot, but not actually in the part that mattered. So I'll put it like this: different teams have different focus. Again, if I share my screen, like now, take for example, if I wanted to, like now, the team I interview on is very networking focused, so they are mostly looking for Linux understanding under networking, like load balancing, understanding TCP connection states, timeouts, all that stuff, right? And another SRE team might be more focused on databases, and they are more focused on, okay, fine, do you understand how databases work? What do you call it? Query times, normalization, denormalization, what do you call it? plans, query planning, database tuning, performance, and all those other kind of things. And all this stuff, they do have Linux backgrounds in them, like TCP sessions. You might know that, okay, fine. How are TCP sessions handled by Linux, right? How is HTTP handled by Linux, right? How is network encapsulation, decapsulation, everything. Earlier on in the talk, I gave an example of this. Where is it? I'm just going to go back on this. So generally, when I was doing that, I took a lot of courses from Georgia Tech. This is actually a master's level course to begin with. So it's very intricately detailed and technical, but it covers everything. Like, I learned about TCP networking from here initially, right? The operating systems, introduction to operating systems, because they break down how the packet flows from the NIC, right, all the way up to your application, right, all the way through the kernel stack to your browser, blah, 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 blah. And I would say you just need enough Linux experience for the role that you're applying for, but typically having good knowledge of all the Linux system stuff is good. And I would highly recommend this course if you want to take a start in it. I pasted the link before, but I'll just paste it again. It seems we have about 9 minutes before the call stops due to time. 11 minutes rather. Yeah. Did I answer your question?
Yeah, you did. Thanks.
Yeah, no issue at all.
All right. Any other question? Let's take like one more. All right. Yeah.
Yeah, Elijah.
Yeah.
Okay, good evening.
Yes, good evening.
Yeah, so I think I joined in late, so I don't know if you have touched it before. I don't know if you have touched this before. So I want to ask that: is there a difference between a DevOps engineer and an SRE engineer?
Oh yeah, great question. I did initially. Let me just run through that again. So right here. So DevOps is actually a culture. So I'll just outline what's here. So it's not just a set of practices, it's a culture that fosters collaboration. Site reliability engineering plays a crucial role in DevOps. So site reliability engineering is the role. DevOps is more a culture. DevOps is more okay, fine. We took what was scattered across different teams. We found what the best practices were for running things at scale, and then we just tagged it under a particular subject called DevOps. Usually, when teams say DevOps engineer, usually it's very not specific. Like now in Amazon, you would usually not see DevOps engineer, right? Like if you check Amazon DevOps engineer, you might see this, but this is branching everything that you need to know. But you never see a particular role, right? If you wanted to work, say, as a networking engineer, right, you would see AWS networking. If you wanted to work, say, as a database engineer, right, you would see database engineer, but you never see anything like DevOps engineer. If you went and checked systems, yeah, you see systems, a systems development engineer, but never DevOps, because large teams never tag everybody on that DevOps that, oh, you're going to do everything, because it doesn't work at scale. I also covered this in a talk way before. That's on the branches of DevOps, just also outline the various systems under it. You see SREs here. The sysadmins, that's the typical ones that administered servers with data centers. Network ops, that's the networking engineer guys. Cloud ops, the guys that do AWS, GCP, or you want to run it. The question someone asked about the solutions architect, generally, if you wanted to run on the cloud, the solutions architect guy is actually doing work on that cloud ops. So he would be thinking of how to run your systems on the cloud, right? etc. And security operations engineers, usually this is a mix of cybersecurity and DevOps culture, etc. DevOps is not really a role; it's more like a culture, basically a standard of how to do things, and then the roles around that now pick certain parts. SRE is more focused on automation. Cloud up guys are more focused on planning and implementation, right? The solutions architect question is a perfect example of what the cloud ops engineer would do, right? And the sysadmins, the typical, hardcore Linux guys, in reference to Abbasi's question. That's like the core Linux understanding is what systems admin guys usually embody. But SRE guys are also required to do so because again, even though you're SRE, you still work along these other branches in different ways, depending on what the role requires.
Okay, thank you.
Yes, no issues.
All right. We have just 5 minutes. So, any other question? Let us take like one more. Anyone has any question?
Okay, I have one.
Oh,
I'm looking at becoming a solutions architect, and I was wondering how to get there, what I need.
Okay. Yes. Solutions architects would usually have they would usually have like experience building. So I know someone asked a question about, does a backend engineer need to be a solutions architect? Does the SRE need backend experience? And a solutions architect might, but remember, solutions architects have different branches, right? They are focused on different things. You could be a solutions architect for the cloud. You could be a solutions architect for databases. You could be a solutions architect for, say, like Lambda, like in AWS, you can be a solutions architect. It really differs, and the scope, and based on what scope you choose, you have a completely different process to get there. So, so like the solutions architect tag is like saying DevOps. Like there has to be something a bit more specific. Like is it in databases? But the generic ones that I can say now is technical writing, right? Because you'll be very client focused. So you're like a sales guy. Also, you're like a mix of sales and technical work. So, technical writing, documentation, and like product management work. Because usually after you implement the designs, you need to follow up with people that will do it. So I'd say those three skills are kind of what solutions architects are really doing. They're more like client-facing DevOps engineers, if I'm being honest, in terms of the SRE and DevOps stack. Yeah. I hope that answered your question.
Yes, it does.
all right.
Okay.
So yeah, we don't have much time, just like 2 minutes. So I hope everyone learned a lot from this session because I definitely did. Yeah. So thank you to our speaker, Manuel. Thank you for joining us at such quick notice. Um,
Yeah, no problem at all. I'd also attached the slides link earlier in an email. Then I would also forward this, what DevOps is really about, just as a follow up on some of the questions here. It might help in a way.
all right. Thank you very much. So I guess this is where we'll end. Yeah, it's been a lovely session. So hopefully we'll have Emmanuel back sometime in the future. Yeah, and
Yeah, no problem.
so see everyone in.
Yeah, thanks for that.
All right, yeah, see everyone in our next session, and goodbye. Have a lovely weekend. Yeah.